Hi guys, right now I'm going to discuss uh, Unit 9 practice problems number 7B and 7E. Now for 7B, you can see we've got carbon monoxide here and argon here. So we have two different gases mixed in a particular container. That container has a volume of 2.5 liters, which means both gases have that particular volume. So they get the same volume here. All right. Now we have 1.5 moles of CO and 2.0 moles of argon. R is the same for both of them, so we don't have to worry about that. The temperature of both of these gases is the same. You can't have a mixture of two gases where each one's at a different temperature. So these two things, or excuse me, these three things are going to be the same. Once we walk through and do our algebra, we see that carbon monoxide has a pressure of 14.9 atmospheres, whereas argon has a pressure of 19.9 atmospheres. And if we want the total pressure, the only thing we have to do is take both of those values, add them together, and we get a total pressure of 34.8 atmospheres. Now, as we move down and we start dealing with this one down here, E, you're given 15 grams of O2 and you're given 34 grams of neon. So the first order of business that we have got to get to is we've got to make sure we figure out the number of moles of each gas first. And you can see I've done that already, 15 grams of O2, 1 mole over 32 grams. This is the molar mass from the periodic table. We get 0.469 moles of O2. We do the same thing with neon, and we get this many moles of neon over here. This value right here is just both of those numbers of moles added together. When we add those numbers together, we get this value. And then to figure out the total pressure, we just plug it into PV equals nRT. Pressure total, not sure what that is. We have a 5-liter container. We know we have this many moles of gas right here. This is our total number of moles of gas. All right. R is always the same because it's always R. Our temperature is 298 K. All right. So I had to convert it to Kelvin. And we just do our algebra, 2.149 times 0.0821 times 298 K divided by 5 gives us a total pressure of 10.5 atmospheres.